All right, very good afternoon to everyone. And on behalf of MTC Global family and IIIE Mumbai, I welcome everyone for this AI Intermediate Certification Program. This is the second in a series, and our third program will be on Advanced AI Certification Program. It's a great pleasure to have with us Dr. Mitra sir and Dr. Banerjee sir. Both are the speakers for this certification program. And we have with us Dr. Sashmita Tripathi, ma'am, the Vice Chairman, IIIE National Chapter. Welcome, ma'am. And also, we have most of the participants from our first basic certification program. I welcome Dr. Mahes Karajikar, sir, from Mumbai, our good friend and past advisory board chairman, MTC Global. In the beginning days, those days of struggle. Thank you so much, sir, for your all support. Now, once again, welcome everyone for this intermediate certification programs, and it's a great pleasure to welcome all of you on board. And I'm sure we have no two best resource persons in the field of AI and robotics. And your expectation would be definitely met. It's a great pleasure to briefly introduce both of them one by one. Dr. G.S. Mitra Thakur is an associate professor in CSE AIML with 18 years of teaching and R&D experience and a Ph.D. in intelligent systems from prestigious NIT Durgapur. His research spans end-to-end MLDL and LLM pipelines in socially critical domains, currently focusing on computational perspectives of consciousness and AI alignment. With over 30 publications and reviewer roles for top journals, he collaborates across academia and industry and mentor student teams. His strengths include MLDL, Gen AI, computer vision, NLP, optimization, reproducible research, and responsible AI. And he is open to collaborations that advance human trustworthy artificial intelligence. Our another speaker for this certification program is Dr. Abhijit Banerjee, who is an associate professor in the Department of Electronics and Communication Engineering at Dr. B.C. Roy Engineering College, Durgapur. He holds a PhD in Artificial Intelligence from the National Institute of Technology, that's NIT Durgapur, where he specialized in reinforcement learning and neuroevolution. With over a decade of experience in academia and advanced research, Dr. Banerjee's expertise spans deep learning, robotics, and autonomous systems. His scholarly portfolio includes 9 international journal publications, 9 conference papers, and 2 patents, reflecting his commitment to technical innovation. Currently, Dr. Banerjee leads the Texas Instruments Innovation Lab and the AICT Idea Lab at BCREC, where he oversees high-impact research initiatives. He is a certified AWS machine learning specialist and holds professional memberships in IEEE, IIT, and CSI. A dedicated proponent of open source technology, he has contributed to major projects hosted by OpenAI, Microsoft, and Amazon. His technical proficiency includes Python, C++, and deep learning frameworks such as PyTorch and TensorFlow. Thank you so much, sir. We welcome once again on behalf of the participants. We have 2 very good resource persons with us this afternoon, Saturday and Sunday, and I wish that program becomes a grand success. Thank you once again. I hand over to Dr. Banerjee and Dr. Mitra, sir. Kindly please take over.
Thank you. Am I audible?
Yes, sir.
So thank you once again for giving us the opportunity to share our knowledge and expertise with you all. And I hope that as uh, Mr. Datta has explained that most of the participants are from the first program, that was the beginners AI level. So, can we know that how many percentage, sir, are from means the previous course have already taken the first phase of the beginner course in this particular audience?
Sashmita ma'am, any idea on this? Approximate?
I think 70% at least we have from the previous course.
Yes. Yes.
Okay. And sir, I have just shared a QR code for a poll. Have you shared that with the participants?
Yeah, yeah. I have posted in the WhatsApp group, but maybe one or two members may not be part of that group. Otherwise, rest of the people are there. I have got it.
Okay. But till now, I have got only 3 responses, not more than that. Okay. Maybe the main purpose of the poll was to actually understand the like uh, outcome of this particular session, that how the session is going to be delivered. So we have a proper planning, that how we have planned, but it will be actually how the participants are willing to enjoy or participate in this particular session. So that's why I have shared a poll, because you all know that AI, machine learning, deep learning is a very vast domain. A lot of things are there to discuss. It will take years if we have to discuss all the things. Another thing is that if you go for implementation, if you go for just identifying any problem from the industry and start implementing, start providing solution for those problems, handholding AI, those that particular scenario has also different directions. So first poll, in the particular poll I have tried to understand was that how many of the participants are interested in learning ML or DL through code, like coding, Python coding, using VS Code and other libraries. So this was our means first aim to understand. And the second was mainly that how many of you will be interested in intuitively understanding the detailed scope of AI in different industry, and just devising a pipeline for that, understanding a solution pipeline for that. Maybe for them they can hire or they can consult the coder or some other no code AI tools, but just understanding the how the problem is going to be solved broadly, and after that uh, devising detailed pipeline for the same. So this was our second motto to understand. And the third question in that particular poll, third option was that because it is now all about means AI, LLMs and agentic AI tools are widely being applied in the industry, and so that how many of the participants will be interested in knowing that how to effectively use different LLM tools for their daily workloads. Okay, so this is again a very big requirement from day-to-day life. Those who are attached with different organizations and administrative roles or in academic roles, so they have to use LLMs for different purposes. So nowadays, a variety of different tools specialized for different purposes are available. So this is also can be a good option to understand. And the another option was that we want to develop your own AI tool for research and production. So if this part will be actually the part of our advanced, the third phase of the coding, where we will be focusing or we'll be using some LLM APIs or some other APIs and directly bringing those into your own project or research, and developing some kind of software tool which you can directly use for your own research and production level. So, but for the first three, just a quick request from the audience that among these first three options, because based on that, our approach of delivery will depend a lot on that. Another thing is that what we have planned so far, if you are not, if you would like to like us to modify a little bit or something like that, if you have something to give such that we can little bit customize it, you will be always welcome here. So first we have decided that we will be discussing the broad ML aspects, different types of ML algorithms, their approaches, and some very important things which is very much essential to know before we jump into any kind of ML project or AI project broadly. Like what are the types of problems, what type of algorithms we have to select, how to prepare the data, then what are the algorithms to select. So this kind of a things is very much essential because nowadays tools are everywhere available, isn't it? Coding is also not a big deal, but understanding what coding is giving to you, or whether it is giving you a correct result or not, or whether you have further scope of improving its performance or not. So this type of decision making is very vital in any kind of real life ML or AI projects, any kind of problem solving projects. So those things we will be touching on, and later on we will be simultaneously Dr. Banerjee, my colleague, he is with me. He will be mainly taking care of that coding part, where you will be learning the different whatever the things I will be discussing theoretically. He will be showing you the practical implementation, starting from exploratory data analysis. So how that can be achieved with the help of like code or any kind of tool directly, maybe through LLM or something like that. And after that, few of the ML algorithms like regression, decision tree, SVM. So those things, how those can be implemented using these like tools or coding. And in the next week, we will be moving into the artificial neural network, which is the backbone of deep learning or this Gen AI, what we were saying. And there also we will be learning some theoretical concepts as well as some practical aspects and implementation, like how that artificial neural networks are can be used effectively, and we can have algorithms like multi-layer perceptron, convolutional neural network, recurrent neural network, with some very small toy problems, just to understand the whole scenario, how it is happening. And at the end, at the fourth day, we will be devoting our whole time on a project. So for this particular purpose, before we select a project for you, if someone from you, from the industry, someone or two or more, can share some problems which are existing in your organization, and which you can share with us, or with the participants, with some primary data available with you. So if you can demonstrate that particular problem with the data and give us to beforehand, so we can also means do a project on that that, and we can show you live that how the whole scenario or the pipeline can be executed, starting from understanding the problem from data pre-processing, then understanding the algorithm, identifying the algorithm, then developing it for production, or like any kind of applications like web applications or something like that. So this is what about the plan we have decided so far. So if you have any input on this before we start, you can easily tell us. So is it okay with all the participants present over here today? Okay. So let us start with is my screen visible?
Yes,
Yes.
it's visible.
Yeah, thank you. Mr. Mahesh, you have raised your hand. Do you have anything to say before you start? Probably not. Okay, so before we start, directly jump into directly problem solving, we have to understand few scenarios which is that what is this whole artificial intelligence, machine learning, and deep learning. In our first phase of training program, we have already discussed in the details the definition, history, and all. But we have to understand that how this artificial intelligence, machine learning, and deep learning are related to each other. So from this particular diagram, we can understand that the biggest umbrella or the set is artificial intelligence and AI. So under that, the machine learning comes, and within the machine learning, we are having deep learning. So how these things has changed? So basically, in very maybe whenever this machine intelligence has come, people used to take all these algorithms, like algorithms used for reasoning, algorithms used for like prediction or classifications. So there all everything used to come under artificial intelligence. So if you can remember, we have mentioned in that particular session that in when we talk about artificial intelligence, we always say that AI is nothing but a field of study where we try to develop some system. It may be a software or a combination of software and hardware to perform some tasks. So obviously, whenever we develop any system, our purpose is that the system will perform some task and will give us some desired output, isn't it? So to perform some tasks, if those tasks were performed by any kind of human being, we would have called him to be intelligent. So whenever any system will perform the task of any intelligent human being, we will call that system to be an intelligent system. So and all the studies which are actually done or made, all the researches, all the efforts that are given for this particular purpose comes under this biggest umbrella that we call artificial intelligence. Now, whenever, again, to remember that whenever we talk about making any system to be as intelligent as human being, so we have to always figure out that what are the things that has made us intelligent. That is our learning capability, our reasoning capability, our decision making capability. So whenever we would like to make any particular system or computing system or any particular system to be as intelligent as human being, so we also have to means make that system capable of learning, reasoning, and decision making in uncertainty or under uncertainty or unknown situation. So whenever we talk about learning, because it is the learning which has made us, we human beings, to be intelligent, we are having a very efficient and complex learning process. So some of them were adapted later on by emulating the like our brain structure, specifically the nervous system, the neuron structure, and we have tried to adapt that basic functionality of our human neural network, and we are developed some algorithm. We have developed some algorithms, and all those algorithms comes under that artificial neural networks that I have mentioned just before. So that will be discussed later in the next week. Now, other than that, already in our statistics and mathematics, we had different algorithms which were popularly used for prediction, classification, regression, all, but those were not termed as a part of artificial intelligence and machine learning later on. So whenever the computational resource, hardware, and other availability of data means increased, then all those algorithms were collected in a particular frame and a particular area of study, and we have named that particular set to be a machine learning algorithms. So machine learning algorithms majorly handles with some statistical algorithms and mathematical and statistical algorithms which were already there before the advancement of AI that we are talking about. And obviously some modifications are also made over the years, and few of the examples are support vector machine, logistic regression, linear regression, decision tree. So all those things are there. And deep learning means whenever the machine learning algorithms face its limitation, means machine learning algorithms works very well whenever the data is more structured, problem is not that much uncertain in nature, and it's not that big or complex enough. So the data set that we will be dealing to solve any particular problem is not that much of vast. or unstructured. So in those cases, machine learning algorithms can perform very well. So in our daily life also there are many problems which does not require any kind of advanced deep learning algorithms and can be effectively solved with the help of existing machine learning algorithms as well, like support vector machine, decision tree and all. So those are coming under machine learning. But nowadays, as our computational resources are increasing, data are getting available more day by day, and most of the data, research data, publication data from almost every organizations are made public. So now people are interested in solving many problems which were supposed to be and which were thought to be unsolvable once upon a time. So with the help, with the availability of this huge amount of data, and at the same time, that computational resource with the availability of GPU, TPU, and other advanced CPU mechanisms, memory, random access memory. So with the availability of this kind of computational resources, now we have got the power to attack those problems from the society which were somehow unsolvable once upon a time due to its uncertainty, due to its uncertain nature. Maybe problems from weather forecasting, problem from agriculture, problem from biology domain, maybe problem from astronomy, maybe problem from geology, everywhere. Okay, so those areas where the problems are majorly vast in nature, very complex in nature, data are mostly unstructured, we have very little information on how the things are happening. So in all those cases, we have devised a different type of algorithms which are mainly means adapted from the basic multi-layer perceptron artificial neural network, and some other more algorithms are also there which are specialized in solving complex problems specifically. So those things are coming under deep learning. So we will be discussing this deep learning concept in the next week whenever we will be start discussing that artificial neural network. Now, where to attack? Basically, earlier model, it was traditional models. So basically rule-based system. Okay. So in the initial days of artificial intelligence, we had expert systems like Mycin, Dendral. So these are some popular expert system around the world, which had made that artificial intelligence domain more popular because people had got some glimpse, some idea that the power of these intelligent systems. Okay, but those were mainly rule based. So human input plus rules were there, which were somehow embedded in a system, in an algorithm, and finally, based on that, the rules were fired and some desired output was received. So, but those were mainly human dependent. Okay, human expert had to be involved for devising those rules. But whenever we're talking about this machine learning, the system is now transferred to a learning system. It's not a reasoning system, a traditional rule-based system. It's now become a learning system, which will learn from the data itself. So we will be giving data plus output. That means what? We are giving the data with the label itself. Okay, for what type of what is the purpose of the particular data? What is the level of the particular data? So if I am talking about the symptoms of any particular disease, so that particular data is also having that label, means whether any person or any patient have already had that disease, yes or no. So label data set if I'm talking about, and if I'm talking about that continuous value or regression model data, so in that case, suppose if I am trying to predict the price of any stock, so in that case we are having the means values of some parameters or matrices which are actually influencing the stock market or the performance of any particular stock, and at the same time we are either having the opening price or closing price as a level. So that means what? This is the label data I'm talking about. So whenever we are talking about label data, I have already mentioned in our previous session, and here also I'm trying to emphasize over here that we call that particular learning algorithm, which will be mainly working on that label data set, we call them to be a supervised learning algorithm. I will be coming to that. But data may be also without label. So in that case, our problem will become something different. Here our problem will not be to classify or regress. In that particular time, my problem will be to means cluster the things. So I will come to that particular point. So here, try to understand, earlier it was a rule-based system, now has become a learning system. And from where it will learn from data. As you also learn from our environment, our senses also collect data continuously from the environment, and our brain learns from the data. So here also the same thing. Here we will provide any kind of a system or a particular learning model, will provide data, and that model will try to find some kind of insights from the data, or try to learn the pattern those are hidden in that particular data. So mainly, if I talk about the lexicon of machine learning, so main purpose, this is very important thing that we have always to remember, that defining the components of the function y equals to fx. So what does this mean actually? We can map any particular event that is happening around us in the form of this y equals to fx, where y is basically the outcome of any particular event which we can find, and x are those parameters or the features which are actually influencing this y. So these x are basically independent in nature in most of the cases, and f is the function which is actually making this possible, which is actually giving this value y from x. So if I am talking, let me take an example. If I am talking about weather forecasting, so if whenever we are trying to predict that whether it will rain tomorrow or not, so my outcome for tomorrow is actually the percentage, the probability of rain. So that is my y. Okay. Now there are various different factors which actually influence the rainfall either directly or indirectly. It may be the temperature, it may be the humidity, it may be the pollution, like AQI parameters, it may be the altitude, it may be the wind, or anything else. So different things are there. Okay, so those are actually influencing directly or indirectly towards the rainfall. So that's why rainfall is taking place. But exactly we do not know how those parameters are influencing the rainfall. Exactly how. We do not have any mathematical formula for that, isn't it? So suppose maybe in our daily life we see a lot of different events. For few of them we can easily define the science, how it is happening. Suppose if I throw a ball with a particular height, we can easily calculate based on the gravity and the mass of that particular ball, and that projectile motion. With the help of, we can get a formula from a physics, and we can easily calculate that where the ball will stop, or how many time it will bounce from the floor. So all these things can be calculated easily because we have a proper mathematics and scientific formula for that. But again, we still do not have any formula to calculate that what is the exact chance of having rain tomorrow if I provide all the data those are available for today. So this is where we do not know this f properly. So in those cases where this f is not known properly, that means how the things are happening, we can see that events are happening, but we do not have proper scientific formula or scientific method to understand or to predict the event exactly. So in that case, but we have y and x, we have every data. We have the historical rainfall data for over 100 years, maybe for any particular region. We have the particular data. We have the parameters, those we are actually have understood that these parameters are influencing the rainfall, and also how much rainfall has taken place. But we do not know the f. So whenever we do not know this f properly, but we have the data, then our target will be to dig into the data, to understand the pattern that is hidden into data, how this x is being converted or is contributing to the y outcome y. So whenever we are trying to understand this, somehow we are trying to approximate this function f. Means we do not know what is the value of the x, but what the f it is, but we are trying to approximate. We are trying to reach near to it. So this approximation is very important in this particular case. And this approximation is made or done by this AI algorithms or machine learning algorithms. So do not get confused with this AI, ML, and DL. Majorly, all are correlated and are used in different terminology in different cases. Okay. But the main thing is that we have the data, we have the label, when we have the Y, we have the X. Now we have to approximate this function F. Now, obviously, whenever we try to approximate any particular thing, we may be wrong in many cases. So initially we made some mistake, then we have to try again and check whether my error is reducing or increasing. So based on that, I change my strategy, isn't it? So the things happen in this particular way. We also do many things. So whenever we find any new things which I have never seen in my life, suppose we have entered in a jungle and found a particular like a water body and some kind of basement are there where we have to step on gradually one by one, and then I can reach to the other side of that particular water body. But we cannot understand how those particular basements or how those particular things work, whether how much weight it can handle, whether it will float or not, or whether it will move from there or not. So what we do gradually, we just step onto it, check its behavior. If we find something wrong, we make our decision, we change our decision accordingly. So after some trial and error, we sometimes find a particular idea, though we do not know that particular how those things work, but we get some kind of an idea that how it is working. So this is actually we call to be approximation. We do not know actually the exact one, but obviously some exact function will be there. It is happening means some scientific rule is there, but unfortunately we do not know that particular scientific formula exactly. So we try to approximate that. So basically machine learning algorithms are nothing but a function approximator. And generally artificial neural network, whenever we will discuss, that artificial neural network is popular today so much only because of that a artificial neural network has the capability of approximating almost any kind of function. So that's why it is also known as universal function approximator. So whenever I have got any particular tool which can approximate any kind of problem, so obviously that tool has to be popular, and that is why it has become. And some other modification are keeping that particular artificial neural network in its core or center. Some modifications or enhancement has been made, and due to which we are getting the more advanced tool like today's Gen AI tools, whatever we are talking about. The basically thing is there, we need some features. Those features should be independent variables. That means those features are independently influencing the outcome Y, due to which, and those features are collected from different resources from the environment. Like for any particular industry, it may be temperature sensor, it may be thermal temperature sensor, it may be a kind of any other sensor. Some cases it may be the stock data, some parameters of different stock. In some cases it may be the performance of different employees on different parameters. So these data are which will be actually used for approximating that function F is known as features. And what is that particular Y which we are actually getting as output? That is the target, because we will predict that particular target based on some new data. And our effort is to understand this mapping, that how X are combined and contributed to the outcome Y. And for that particular purpose, we need some algorithms to understand that how these X's are being mapped to Y with the help of this function F. Okay, so whenever these algorithms we are using and we are finding that these algorithms are working fine, okay, we have to make some tuning or something like that. And whenever we are finding that, okay, now my algorithm is fine and it is the error that I am getting is not that much, or it is under the tolerable range, and it is also performing well with new data set, we call that to be a model. And whenever it has become a model, then obviously we can deploy it for our real life production purpose or problem solving purpose. And in between, here we have a term called training. Training is mean again the same thing. Iteratively, you make some effort such that the error is minimized from your, what is the error? Error is nothing but the difference between the predicted output and the actual output. So as you all know, actual output, what actually has happened, and predicted means what you have predicted that it could happen or something like that. And these things already you know, most of you, that supervised learning algorithms comes in two categories: regression and classification. Regression means simply predicting the continuous numerical values, and classification means predicting the discrete categories. So I will not give more time over here. And unsupervised learning, as I have already said, that whenever we have the data, but we do not have the label. Okay, so it comes in two categories basically over here. Like one is clustering, another is the dimensionality reduction. It is saying clustering means grouping the data points by similarity. Okay, we do not have the label, we do not know what that particular groups are actually meaning or actually symbolizing, but we can differentiate that, isn't it? So like that, whenever I get a collection of different coins of Indian rupees, like 2 rupee coin, 5 rupee coin, and 1 rupee coin. Okay, now if I give any person from any other country who have no idea about Indian currency and asked him to segregate these coins, so for this particular segregation, he should, when there is no requirement that he must know the Indian currency, that this is a 5 rupee coin or 2 rupee coin or 1 rupee. Based on the features of the coin, like shape, size, or the things, the number that is embedded or given at the top of the middle of that particular coin, based on this particular feature, he can segregate it. But he has the no capacity to tell that this particular collection is a collection of 2 rupees coin, this particular collection is a collection of 5 rupees coin, or this particular collection is a collection of rupees 1 coin. This labeling has to be done by us, basically. So this type of algorithm will make different groups based on the patterns and the features present in that particular data or in this particular data, and it is capable of segregating those things. Okay, so this is what we actually call unsupervised learning, and clustering is one of them. Okay, and dimensionality reduction, it's again it's very useful kind of a thing in our like complex problem solving, where we simplify complex data while keeping the structure as it is. Meaning what? That whenever we are seeing that particular data from a lower dimensional point of view, it is becoming very complex. We are not able to understand. So in that case, we reduce the dimension. Okay, suppose I have a complex 10-dimensional data, and we are finding that this particular dealing with this particular data is very much difficult. So what we do in that particular case, we reduce that dimension. We just do what? We just reduce its dimension and find that whether any kind of or deriving the insights from it or understanding its means pattern is becoming easier or not. So in that case, simplifying the complex data. Okay, but simplifying does not mean I am eliminating the complex features, all the features. No, if we eliminate features, that means we are losing some information, some critical informations. So my prediction or learning algorithm will fail in that particular case. If we, without knowing the importance of the feature, if we can directly eliminate the feature, the parameters, that is also a type of feature reduction or dimension reduction, just directly eliminating the features. But the risk is that if we eliminate or remove the features without knowing its importance or some important features, then my machine learning model or the learning model will face difficulty to converge. Okay, but this type of dimensionality reduction is doing what? It is reducing the dimension but keeping the structure as it is or almost as it is. Okay, so one of the algorithms is the principal component analysis, and it is used for compression and visualization in many cases. And the reinforcement learning, that is the learning we human being are very good at, and most of us learn many things, whatever we have learned today till today, through this type of learning mechanism, where we learn from some kind of reward or penalty. Okay, so like agent is there, already I have said, agent which is actually performing some task. Okay, which is here, whenever we are talking about agent, we are talking about an AI agent in which is capable of performing some kind of intelligent decision making, and it will be interacting with the environment directly. So a very good example can be a robot. So think about a human and robot, okay, which is like a lot of sensors are there. It has some cameras, it has some other sensors with it. Now it is directly interacting with the environment, is scanning that environment. Okay, and based on that particular scan, it is making some decision, or it is either it is moving or it is picking something up or something like that. So something like this, whenever agent is interacting with the environment with the help of with the help of sensors. So after that, it will having some kind of processing in it, and based on that processing, it will perform some task back to the environment with the help of actuators. Okay, so now after performing the task, there is a policy to identify that how accurate that particular task was. So based on that, some penalty or reward mechanism is there. As you all know that whenever a child at your home, suppose whenever you ask him not to touch this or not to touch that, in many cases he or she will not listen until and unless he or she faces some difficulty in doing that. Suppose there was a kind of a hot object before, earlier you have asked him so many times, do not touch that, do not touch that, you will get burnt or something like that. He or she will not listen. But once he or she touches that particular thing and feels the heat, after that he will never go back to that particular place. So at that time means he had performed some action, and based on his action he had got a penalty, isn't it, that it is harmful. So his brain has learned that from now onwards, do not touch that, because it may damage something. That means here mean it will be making the goal away from where you are right now. And reward means that opposite one. Whenever you are performing some task and you are going nearer to the goal, you will be rewarded, such that that particular policy is given more emphasis and you can go much more nearer to that particular goal. So basically in robotics and in other kind of gaming situation or in some other industry also, this type of learning mechanisms are used, which is basically a policy based learning with some kind of reward and penalty. Okay, so policy is nothing but a strategy the agent learns. So this policy agent will learn after some time interacting with the environment. Okay, so this thing has to be done, and obviously the goal in this particular is maximize the cumulative award. Means more award means you are more nearer to the goal, or vice versa, more nearer to the goal you are getting more reward. So whenever your target here will be to maximize this reward. And most of the popular, many of you might have heard the name of AlphaGo. So so this is actually use the reinforcement learning algorithm, and for other purposes in robotics and dynamic pricing, this reinforcement learning is also used. Any questions or queries till now? Anyone from the audience? Any questions? So I love to have some questions or discussion in between. Otherwise, I'm not able to understand whether you're listening or not.
So far, so good. Pretty clear. I think when we see data and different examples of how do we put it, then probably we may have some questions.
Okay, sir. Thank you so much. Okay, so the basic goal here is to generalize, isn't it? not memorize. So generalize meaning what? We learn from some sample specific data, but obviously those data is for our learning purpose. Okay. Now, if that learning which I have learned from the sample data, if that learning is also suitable or also become or applicable for new data sets which I have never seen or the model have never seen earlier, and for those data also it is performing well, then we can understand that okay, now the model has learned actually. Okay, so this is actually called the generalization. But if it has learned only, it will perform only with the data set with which it has learned, and it is failing drastically whenever it is facing some new kind of data, we will say that no, the model has not learned at all. So generalization is not achieved at all. So after learning, maybe three different types of problem we can face after learning, after we develop any kind of ML models. Model can be,
इसका सूजी वाला भी चढ़ा दीजिएगा दीदी. हाँ, सब्जी
model
जब
can be of,
चढ़ा दीजिएगा. सब्जी चढ़ाइएगा ना तो उसको भी.
okay, so model can perform in three different ways. So after you have trained a model, your model can be evaluated in three different ways. Either it will underfit, that means it is too simple, it is the optimal fit, that means okay, generalizes well and captures and understood the actual inherent signal which were hidden in that particular data set from which it has learned, or the overfitting. But before I go for this particular thing, I will try to explain what is present over here in this particular slide. That whenever any ML model will be trained, okay, we face a trade-off, which is a very important one, that we call to be a bias-variance trade-off. Okay, so what is bias and what is variance, that we have to understand. So ML model is given with the data for learning, any kind of learning, if you're talking about classification, regression, whatever may be the purpose, but it has given with some data. Okay. Now, after some iterations in the algorithm, it tries to understand the data, it tries to understand that f that I was talking about in y equals to fx. But in this process, what may happen that the model has got some relation, but with some wrong assumption, which is not correct. Okay, like suppose I have two variables, x and y, and suppose I am z equals to x plus y. Okay, now I have seen a data x equals to 2, y equals to 2. Or suppose, forget about, no plus is not there. So in a input field, I have x, y, and the output field, I have z. Okay. Now, the value of whenever I have given a data, like 2, 2, so x is 2, y is 2, and I found that z is 4. Or it may be a multiplication operator, that is 2 cross 2. So with this very first example, if I assume that it is a plus operator, but whenever I am finding that whenever it is 3, 3, it is 9, then I have found that no, it is not that, it is wrong. It can be a multiplication operator. So whenever model assumes something very early, which is somehow mapping the outcome data, but that is not actually the case. Okay, so error from the actually erroneous assumption. Okay, so that particular thing is known as actually the bias, means model is biased to a particular pattern it has assumed, which is not actually the generalized pattern. And another thing is, which are somehow opposite to that, that is variance. Variance means what? Model is not able to understand that what is actually pattern in that particular data. So due to which what is happening, slight fluctuation in the data, the model, performance of the model is being affected highly, in a huge way. So slight change in the data, huge change in the outcome or the performance. So this particular sensitivity to fluctuations in the training data is called the variance. So we can understand from where that situation may be different. So this is the trade-off. If I try to make it very simple, it will be biased. And if we do not try to make it very complex, it will become, the variance will be high. So both are not my expectations. My expectation is to have a balance between them. So suppose in this diagram from the leftmost side, suppose if the center point is my actual function, that f, actual one, and the model is also putting its output here in the center point. So what I will say, that the variance is very low. Okay. But here in this case, this is actually my desired f or the desired outcome. But all the data points, all the predictions are somehow here, though it is there clustered. Okay. Here the bias is low in that particular case. But this is also not expected. Now, whenever the variance is high, what will happen? This cluster will not form. Means model will not be able to converge in a particular area or in some cases. So data point will be fluctuating. A small change in the data points, the performance of the model will also become very much fluctuating. Okay. So in that case, it will be very much noisy. So it will be calling that to be a high variance. So my expectation, obviously, you know very well, that is not that high bias or high variance. So my target will be to come to a particular point where these two are balanced, isn't it? Any questions from this? Okay. So in this diagram, if it is any confusion, try to understand the center of the target is actually truly underlying function that we are trying to predict. That is the ground truth. Okay. And all the dots are basically the prediction that are made by a model when trained on different samples data. And obviously the worst case is it will be very high variance, very high bias. Okay. So predictions are scattered and also far from the center. So in that particular case. Okay.
Hi.
Now, yes.
Can you explain with an example?
Which one? This one.
This bias trade-off. Can you explain with a real data example?
Real data.
With some data example, then I can internalize it, you know.
Yeah, sure. See, try to understand. I have a data set, okay, and I have a model. So it is not about any particular data set, something like that. I have a suppose stock market data set. Okay, so I have a pattern parameters of some like ratios which are actually measuring the performance of stocks in the opening or closing price of the stock. So like this, I have historical 1 or 2 month data. So that is a data set maybe. And for learning that particular the pattern of opening and closing price, I have developed a model, a regression model. Okay. So now this regression model, the behavior of this regression model may vary based on the based on my choice of the model or the pattern of the data or something like that. Now my target will be, the optimum target is what? Optimum that my model learns that pattern that is in the data correctly, such that it, whatever the pattern that is hidden in the data, like the ratios and the opening or closing price. So there is a relation, and the model has correctly approximated, almost correctly have approximated that particular relation. So if the model correctly approximate that particular function, this scenario, the first scenario will happen. The target, that is my center, and the predictions are right on the target. But here in this case means one, whatever the pattern, actual pattern is, it has also learned that pattern and predicting based on that. But in the second case, the actual pattern is somehow here in the center, but it has learned a pattern which is not the actual, but it is clustered, means it has identified another pattern which is not the actual one, and all the predictions are going to that particular pattern. So that's why clusters are getting formed over here, which is far from the center. Okay, so that is actually the low bias. And whenever it is the high variance case, means what? It is not capable of getting concentrated anywhere. That means what? Different predictions on different data sets are in different place. So nowhere it is clustered. That means what? Model has not learned anything. Whenever the data is slightly changing, the outcome is also like changes. Okay, so but here one thing is there, the all the data are nearer to the central region, maybe. So it is called actually the overfitting. I will come to the next slide. And in the worst case, what will happen? Neither it will be clustered anywhere in the center, or nor it will be clustered anywhere outside the center. So in that case, the model is fully not learned anything. It is not converging anywhere. So our target is to get a balance, not exactly very high bias or very high variance. So this graph will make this idea more clear, I think. So see, x-axis is representing the simplicity of any particular model. Okay, simplicity here you may consider more number of parameters mean more complex, and less number of parameters less complex. In a very layman term I am talking about. Okay, so when my model is very simple, okay, the bias is generally high. Okay, that means it will be saying that, suppose sometimes what happens now, when some easy questions are used for learning or teaching any particular student. So some easy questions were given to that student and he has confidently solved. So 3 or 4 easy questions he has solved, and he is thinking that, okay, I have learned everything about that particular topic. Okay, suppose for differential calculus, I have given you a very means very simple function to differentiate. 5 or 6 functions I have given him to differentiate, and he has successfully solved it, and he is now thinking that he has mastered in differential calculus. So what will happen? Whenever he will be facing some complex differential calculus problem, he will fail. So whenever the learning is based on model is very simple, initially the bias will be higher. But as the complexity will increase, the bias will reduce. And as the model will become complex, bias will be reduced. So more complex model, less bias. But for the variance, what will happen? When the model is very simple, it is having a very less variance, because the model is simple, the fluctuation in the data pattern, understanding the pattern has become very simple. The model, maybe I'm not talking about the actual, because model has estimated like this. For model, it has estimated that this is the simple model and this is the actual relation, it is happening. So I have understood the pattern hidden in data. So initially for the simple model, the variance is low. But as my model will get complex, its variance will increase. And for a very complex model, high variance is noticed. So in that case, obviously my target area will be here. that we call to be the sweet spot, optimal complexity. So my parameter tuning, the selection of the model will be such a way that we have a balance between a bias and a variance. So that is actually called the bias variance trade-off. So basically, this is the pipeline for every kind of machine learning project that we do. So first step, the understanding, the business understanding has to be there, for which I am actually trying to implement that particular software or the algorithm. That is very much important. So once that is understood, I have understood my goal, and based on that, I have understood now that what are the data do I require for that particular, to achieve that particular goal, or training a particular model or devising a particular model. Okay, and what type of data it will require. So once I have identified that particular data, I will collect it from that particular environment. Like for if I am talking about agriculture, so from agricultural data, if I'm talking about from stock market data. So based upon that particular domain, I will collect some related data, which is relevant data. Okay, so once that is done, then that data is called to be the raw data, and raw data obviously is not suitable at all directly for machine learning training. Okay, so as you all know that if the data is not structured, cleaned, or formatted data, that machine learning will drastically fail. It is not the problem with the model. Okay, it is the problem with the data. So that we have to understand the very first, that in ML terminology or in this AI domain, we always use this particular term, garbage in, garbage out. So if you give erroneous data means unstructured, unformatted, unclean data. So whatever machine learning algorithms you apply is not going to converge well. It's very simple like that. So the very first step is coming, cleaning, formatting, and some feature engineering may be required from problem to problem. And then some exploratory data analysis has to be done to understand that what is the inherent pattern in the data, means what type of algorithm may be suitable. So it is not that like that we have got a data set and directly apply a model, because we have so many different models now. Resources are free almost. We have Gen AI, LLM tools. Every resource has try one by one. It is SVM or regression or something. No, it's never the case. Whenever I have got a data, I have to clean it. I have to format it. If required, some in feature engineering has to be there. Like if I have given my date of birth, from there I can calculate my age. So that age that we have created a new feature. So this can be engineered feature. So this type of different feature engineering can be achieved. Okay, and then some exploratory data analysis, some visualization has to be done, because we human beings still have a lot of intelligence to identify just from visualization of the data that what type of data it is, what type of function may be inherent over here. Okay, so based on that particular visualization, your next step will be that selection of what type of algorithm is required. So getting a proper insight, proper understanding about the behavior of the data, you need to do some kind of exploratory data analysis, which will be explained by Dr. Banerjee just after my completion of this presentation. So already I have said it. So this is a cycle, ML life cycle we have to always do. So selecting the architecture, then training the algorithm, validate it, then optimize it, and then again do these things. So this is cycle that we have to continue. So you rarely build just a model. Many times you have to build many models, and then you have to select the best one. And the ML life cycle, some evaluation, obviously how well your model has performed. For checking that, you need some kind of performance metrics that you need to check. I have already discussed in my previous sessions, and this confusion matrix is different parts, different parameters. I will also discuss later on whenever I will be discussing classification model using ANN and all. This is another thing for those industry people or those who like to develop models for our own industry purpose, actually, which will be deployed in real life. So for this particular slide is very much important, that continuous monitoring, it is very much required, and drift may happen because the model that I have developed today may be functioning very well today, but that doesn't mean it is future proof. No, it's not like that, because the model has learned from some data. Okay, and those data maybe were relevant for that particular time period. Now everything is changing, the whole global scenario is changing, if I am talking about. So obviously the pattern is also changing in the data. So maybe a model which used to perform very well 2 to 3 years ago may not perform well in today's situations. So in that case, we have to retrain my model with some new data set. So it is a continuous process. We have to continuously make our model learn with new data sets. Okay. An example was very good, that many scenario changes like after post-pandemic behavior. Okay, so this is a continuous loop we have to understand. Okay, so after this we have understood very well the three main things. One is that whatever the ML models or DL models we will learn or will develop in future or in many cases, those are nothing but function approximators. So is basically it will try to approximate that particular f in y equals to fx. And ML earlier shift from that logic-based, rule-based system to a learning functions from data. That is a based on probability. And the main thing that we have to understand, the balance between bias and variance to achieve generalization. If any of this is high, so if you can remember here, if in this situation, if the bias is very high and the variance is low, so in that case, my model will underfit. Underfit means it will not perform at all. So neither it will perform well here, nor it will perform well over here. Overfitting means very high variance but low bias. So this is also very bad. Okay, means it has here. Overfitting means what? It has made the model too complex. I mean, it has tried draw. My purpose was to draw a line which will be well fitting this particular data points. So my option was, if I draw directly a straight line, meaning what? It will fit for few data points, but most of the data points will not be fitted over here. But a very optimal fit can be this particular line. So this is my target, or this is my goal. Neither this. So what the problem will be over here? It has learned the training data set very well. Each and every dot it has connected. But if you give any new dot, so for that again it has to draw a particular line. So for a new data set, it will not perform well at all. Neither this one or not this particular one. So underfitting and overfitting, these are the two major problems. And underfitting will take place whenever the bias is very high, the variance is low, and overfit will be problem will arise when variance is very high and bias is very low. Okay, so any questions from this discussion? Any questions or anything you'd like to share or to comment on? If you have any question, you can also ask me in chat. No problem.
Sir, can you please share the last slide, that takeaways from this?
This one?
Yes, sir.
The last sentence is very important, from certainty to probability, because most of the real life problems are uncertain in nature, and we all know that very well. That uncertainty comes due to the lack of knowledge. So those areas where our knowledge is limited, we do not have full knowledge in that particular domain, uncertainty will obviously comes. Okay, and in that case, everything will be approximation and stochastic. We are collecting a lot of data from outer space. Okay, so but we do not have idea what exactly those data mean. So this is the particular place where we can apply DL and ML for getting some kind of insights from biology, from taste data, from everywhere. Again, some biological behavior, we still are not able to understand how the things are happening, maybe from a very inside of the smallest cell to a particular organ. But data, clinical data are with us. As our knowledge is not clear, that it is uncertain. We are not able to understand that how metastasis is occurring once a cell is becoming malignant. But we have a diagnosis data. So scientists are trying to understand the behavior of the cell, that how these cells are becoming malignant and how the metastasis in cancer is occurring, the kind of a thing. So this is where the places, these are the areas where we have a scope of applying this machine intelligence that we call, either we call AI, ML, or DL, whatever it is. So, and the very thumb rule, what I follow for applying is that check whether the problem is uncertain in nature, whether the data is unstructured. So if this is the thing, if this is true for any problem, that problem is a suitable one for deep learning or machine learning. So any question, any other questions from the audience? No doubt. You can also share your opinion, because a lot of experienced persons from industry, academics are also there. You can also share your opinion and understanding on this particular topic. Okay, Dr. Banerjee, are you here?
I'm here.
Okay.
Am I audible?
Yeah. So if you do not have any questions, so I will request Dr. Banerjee to demonstrate that how the things that I have already discussed, that the data preprocessing and some simple machine learning things can be done. So he will be demonstrating with the help of some tools, coding tools, and it will be very much effective for you to catch. Okay, so hand over to you, Abhijit Banerjee.
Yeah, Dr. Thakur, let me share my screen.
Yeah, it's visible.
Is visible? Yeah.
Yes.
So first and foremost, I'll be clearing up some notions regarding AI, ML, DL, and all, which Dr. Thakur has already touched upon. But I'll be saying this in a very brief, concise manner. Let's go with the first one. Let's say we have a simple function y is equal to f of x. In this particular function, the two variables y and x are the two independent variables and the dependent variables, whereas y is known as the dependent variable because y is based or derived from the values of x. The function f defines what would be the value of y. In real life, as Dr. Thakur has already said, that certainty, we were talking about certainty, and then there is probability. If we know this function, if this function is known to us, do we really require to find the actual definition of x or f, the function? For example, let's say if I use my electric vehicle battery for a long time, my battery will be draining out. That entire process has a particular equation. How much time you have spent for your electric vehicle and how much was the initial charge, and after how much hours, what would be the charge left in your battery. that has an equation. Do I need to have a probabilistic theory behind it? Do I need to use AI behind it? Do I need to use ML behind it? We do not. Where we have a particular equation set to find the value of y, given the value of x, we need not go for any sort of AI, ML, DL, anything. There are times where this function f is not defined. This entire function f is not defined. Times where we do not know the value of f, then and there, only then we require this particular AI and ML. In short, in gist, if you are certain about something where you know the value of x and you want to find the value of y and you have the function f defined, go with the equation that you have in hand. If you do not have this f defined, if this f itself is not known to us, what is the relationship between y and x, is if this is not defined, then we go for a AI, ML or a DL solution, which provides us a probabilistic, stochastic or an approximate value of this particular equation. It provides us this f. What AI does is provides us this f. That was one of the things that I wanted to say. Another one was somebody asked about bias and variance. Let's go with this first. This is a circle. This is a circle. Let's think of this as a dirt board. D-A-R-T, dirt. Things that we throw on the board and it sticks on the board. If the values, let's say we are throwing 5 dirts and all of my dirts are falling here in the center, then we have very high bias. What is bias in English and what is its meaning in Hindi, English, or whatever our vernacular is? Our attenuation or our inclination towards a particular thing every single time is called as a bias. So similarly, if my dirts hit this center of the board every single time, then we have a very high bias and it has got very low variance. V is less and bias is high. Variance means how deviated they are from each other. They are not deviated from each other. They are packed in a single block and they're in the bullseye. If they're in the bullseye, we have got no problem. But if our predictions all land here, away from the bullseye, but still very compactly packed, then we have still low bias. We are not spreading around. We are not going with a high variance, but all our predictions are wrong. We should have hit the bullseye, but we were hitting outside of it. Still, we have a very high bias. That is also not right. It simply means that all our predictions are very closely packed and all of them are wrong. So henceforth, we have 1, 2, 3, 4, 5, 6, 7. 7 dirts have been hit. If I want to predict what would be the position of my 8th dirt that I will be throwing next, then my prediction would be somewhere near here or here. But it will never be here or here because we have very high bias and we actually know that yes, we are going to hit here only, and that will be also wrong. So another way of thinking is we are hitting everywhere 1, 2, 3, 4, 5, 6 and 7. I have hit 7 dirts. All of them are outside the bullseye and they are not closely packed. If they are not closely packed, which means that they have a high variance. Now they have a high variance, we required a high bias. And in spite of having a high variance, which we do not need, we also can see that all of them are wrong. It has not hit the bullseye. So eventually what we require is all my dirts should hit in the bullseye 1, 2, 3, 4, 5, 6, 7, and they should not have a very big variance. Had there been a very big variance, let's say we have a variance of this everywhere. I'm hitting everywhere, but not in the bullseye. Then if I want to hit the 8th dirt board, dirt on the board, that eighth dirt probability, the probability of the eighth dirt hitting this bullseye is also 0. Why? Because I have hit everywhere except the bullseye, and I will have got no inkling of where my eighth dirt will hit. Initially, if there was a high bias, like this, I would have known that my eighth dirt, let's say with this green dot, would have hit exactly here or here, very close to the earlier ones. But in the case of high variance, we have got no way of saying where it will hit. It might hit here, it might hit here, it might hit here. So in GEAST, we should have a low variance, high bias, but at a particular juncture point, which is at the balanced point. The balanced point is at the center of this bullseye. So if I want to hit this high bias, I should also make sure that the variance is also low, and vice versa. This trade-off is very, very important. I hope this makes the answer clear for Mr. Murli. Mr. Murli, are you there? Yeah, listening. Go ahead, Murli ji. Boliye.
Yeah, I'm getting the point.
Good to know.
Yeah, if you can give another example also, that will be better.
Yeah,
Is it okay
I'll
now?
be showing you right now. For example, here. Is it visible?
Yeah, sure.
Yes, visible.
Let's say we have a date, product, category, price, quantity, and revenue. Let me sort this thing by category first. I'll be going with a particular category only. Let's say accessories. Now with this accessories revenue, my objective here would be to forecast the revenue of this particular category. You will notice that on the left hand side we have a data point. We have data, date. This date is also almost synchronized. It's 5 January goes on to up to 12th. Yeah. So January to December we have the data. This is for the year 2022, 2022. What about if I want to forecast the data or the revenue of this accessories category for the month of January, February, and March of 2023? Then I would have to need to know what was the trend, what was the progression or decline in the last year. Let's say in this particular example, we have revenue starting from 1500, 2400, 1200. If I draw these revenues on a particular plot, what would be the values? Let us do that with a simple procedure. Let's say we have a data point. Let's say this is my month or date. This is my date. This will be my revenue. Now, if I go back, it's 1500, 2400, 1200. So one of the point will be at, so let's say here, 1500, 1200, it will be almost, one moment. First one was 1500, second one was 1200, very fine. No, sorry, second one was 2400. Second one, let's say it is at 2400. Then one was 1200. Then one was 1000, nearest to this. Then is 1600, almost here. Then is 1200, almost here. Then is 900, almost here. If you go like this, you get this point that what do we see? Do we see a cluster of points, or do we see it is spread everywhere? If I do not see it is being spread everywhere, then we have a high variance. For example, this particular data points, let's say this particular data points are almost clustered around 900 to 1700. What about this? This particular data point is outside this particular cluster or bias ke bahar. If this one is outside this cluster, then this is known as an outlier. OUTLIER, outlier. Now this outliers has to be removed from our predictions because they will create a lot of problem. Why? Let us understand it intuitively. Forget about AI, forget about ML, forget about DL. Let's think about this. I'm in a class, I'm trying to figure out what would be the marks of my students. Everybody is getting an average marks. One of them stands out. He always, not always, sometimes he gets the highest score, sometimes he gets the lowest score. Very, very flimsy prediction for that particular student. What would I do if my authority asked me to predict the trend of the class or predict the forecast of the class average CGPA in the next year? Could I include that one student who is always fluctuating or not? If I include that student, then my prediction will be all going wrong because I'm not taking the average, I'm also including an outlier. But if I leave that person, since all of them are in the same bias, I will get a proper prediction henceforth. So one of the important thing is I should be taking this outlier outside or remove this outlier from my prediction since it creates a particular thing in common, which is this is creating a high variance. These points are creating a high bias, the points at the bottom, whereas the other point, which is this outlier, is creating a high variance. So high variance points should be cleared off. Had this data been almost like this, I mean, every other point, I have got no way of saying what goes where. One point is here, one point is here, one point is here, another is there, there, there. So my cells of that particular category accessories has gone haywire. Once in January, it is a low cell, February, very high cell, then a very low cell, then another big cells, then medium cell. This type of high variances will always create a problem while forecasting the next prediction or the next year's prediction. What we require is the point should be almost clustered, very low or very low variance and high bias, such that if I fit a point or if I fit a line in between them, then I can predict what should be the next forecast of this particular points. If one of the point in this chart, let's say this one goes here, then I will have to remove this because for that single data point, I cannot jeopardize my entire predictive analysis. This is one of the primary thing that we need to do with the data on receiving the data, which is outlier detection and outlier removal. We cannot have any outlier in our data, which will eventually make our predictions all go wrong. Am I clear with this bias and variance trade-off example with this thing?
Okay.
Okay. Now I'll go with the actual, this blue line that I drew is actually not straight because I did not draw it straight. It should have been a straight line. Let's understand why it is a straight line, why not a curved line, and what is the mathematics behind it. The entire word that I said called as a prediction can be summed up into two independent, let's say for the timing, two independent parts. One of them is regression, another one is classification. Let's be very serious about it and make it very simple. There are two types: regression and classification. We'll try to understand what they are right now. So what is regression? Regression says I need to predict the future data point given that we have a historical data in the back. I'll go very slow. I have a historical data in the back and I need to predict based on that historical data what would be the value of the next future point. What classification does is it does not predict the future point. What it does, it clusters into independent classes. For example, the same analogy of my own class where I have got people, students with many CGPAs. Many of them have 5.6, many of them have in the range of 7.8 to, and others have between 8 and 9. Well, what do? I need to classify them into segments or clusters. So that becomes a clustering. Now that I have clustered them, let's name them. Just name this clusters. Example, students in between the range of say 5 to 6 in CGPA are called as the weak students. Students at the range of 8 to 9 are good students. Students in the middle are called as the progressive students. So I have labeled them. So there has to be a model which can classify them based on their classes. Are these students weak, moderate, or progressive, or they are actually going ahead, or they are good students? So this classification. Another way of example would be you are doing it for every single day. For example, you go to google.com or wherever you want to search your images and you search for say red car. The moment you typed in the red car, the algorithm of Google in the back end will search for cars which are red in color. So it has got millions, billions of images, in fact in trillions. So how does it classify each and everything? So first there are two words. It has got red, it has got car. We have to go from the very last end. It has got red, RED red, another one is the car. So it will start with the word car first. It will search for all cars. So it has got trillions of images. The classification model will first classify all the images based on their classes. It will identify what are the cars, and after it has classified what are the cars, then it will classify by number. So it's a two-stage classifier. Regression is forecasting the future based on the previous historical data, whereas classification is a model to categorize independent data into separate classes. Those are absolutely different. The moment here, for example, there is an example here: fraud versus legitimate, spam versus inbox. Such type of examples actually confuse people. The moment I say fraud versus legitimate, this is a binary classifier. It has got only two independent classes: fraud and legitimate. Spam versus inbox, two classes: spam and inbox. But in real life, we might have more than two classes. We might have to classify in between 5 or 6 classes. Now, the moment I say multiple, henceforth I will be using this word called as a dimensionality. Dimension. The more the classes, the more the values I will have, more the dimensions. Here also we will have dimensions. Example, let's say in this particular sales forecasting one, I have a date, and based on this date and based on this quantity, I have to forecast the revenue. What are my X and Y values? I initially started with Y is equal to f of X. So what are my Y equals to f of X? So here from this data set, What are my X? My X is date, my X is quantity, and my Y is revenue. So I'll have to put this thing there. So my X is date. One of them is date. Another one is, what was that? Quantity, QTY. And what is my Y? Y stands for revenue.
Revenue.
Yeah. So based on the values of date and quantity, I have to forecast the revenue. Now, as I was saying, for dimensionality, had I been doing this forecasting based on only date or only quantity, then the dimensionality of the data is reduced to 1. Very low dimension. Here we have 1 dimension, we have 2 dimensions. So we are dealing with 2 independent data points. But in real life, in real business applications, this dimensionality D can reach up to 1,000 or more. So what we need to do? If dimensionality reaches 1,000, then we have a problem. Had this, for example, here, let it be based on only quantity. Do I need an AI model for this? Do I need an ML model for this? I do not think that any business major or a minor can sit down and say कि आज इतना quantity है, then the next day certain quantity will be there. That comes straight from our own human intuition. We do not need a AI model for that, or a mathematical or a statistical model for that. But the moment this dimension reaches enough that humans get confused, we cannot figure out this F. We have a problem figuring out what is the relationship between X and Y, because number of X dimension has gone beyond our human comprehension. Then we need all these AI models, all the statistical models or ML models. So in short, in gist, when you have low dimensionality, data is clearly highly biased, it is all packed together, use your own head, use your own statistics, use your own equations. The moment dimensionality reaches 1,000, or maybe it is when it is beyond human comprehension, use AI and ML. And the way to use it is purely statistics. AI, ML, DL, all these things are based on pure mathematical statistics. We have given them a big names, big jargons, but at the end of the day, they are nothing but clever statistical methods. So today we are going to learn about one of that statistical methods. Am I going very fast, or is it okay?
Perfect. It's good.
Okay. Okay.
Take it. Thank you. Now we'll go with one of the independent statistical models that we were talking about, which is OLS, ordinary least squares. Whoever is in the field of engineering or basic sciences, or even a normal second year graduate will know about OLS, or ordinary least square. But what we need to understand is the importance of ordinary least square. It might be very simple to understand, but it has got immense implications. As we were saying, let there be a company who has been spending a lot of advertising money to get some revenue. They have charted how much they have spent. They have charted how much they have spent, and they have charted along with the sales revenue. What do we see from this particular data point? Do we see high bias or high variance? Are the data packed, or are the data all around the chart? I'm just asking from you. What is your opinion as a human intuitively? Is it packed, or is it all around the chart? Or is there any region where it is packed, and is there any region where it has gone with a high variance?
It's somewhere it is fact and somewhere it is not.
Yeah. So when they were actually starting with this advertising one, when they have already started, just started this particular region, it is packed with a high bias. But the moment it has gone with the very high advertisement spending, we see a bit of variance. Now, at this moment, what should be the business strategy of that particular company who has been spending? They should have actually stopped here when they were getting good predictive analytics. They started with spending more. Obviously, the revenue was more, the greed was more, but the moment it has become the greed has gone more, what about when they spent $30K? When they spend $30K, do I have any way of saying or any good way of saying or predicting what should be the value of this revenue? Should it be 300K or should it be 250K? We have got no idea. There lies the implication of using a statistical model to find out the prediction of that. Will it be a good prediction? No. Why? Because we have a high variance section here. Had it been almost packed together, we could have certainly said that this would be the optimal value. AI, ML, DL statistics will not provide you the exact value of prediction. It always provides you one particular thing called as a suboptimal value. Suboptimal. Your optimal is the actual number which you actually require based on the history, but you will never get a actual physical number. You will always get a suboptimal number. So given this chart where half of it is biased and half of it is with a lot of variance, human intuition has failed. We cannot predict by drawing a single straight line that this when I spend 30K, I should get 300K as revenue. When human intervention fails, we need to go with statistical models. I repeat, I'll say that AI MLDL is all about a clever statistical model. We have just put names to it. Jargons are good to hear, but at the end of the day, they are all statistics. So instinctive, our instinctive trend is if I draw a straight line, a 2-year-old can also say that the trend is high. Trend is high means if I spend in very layman's term, if I spend more money in advertising, I should get more revenue. Is it linear? We don't know. Is it non-linear? Obviously, we can say from it is non-linear. Question in business will not be what is the trend, high or low. It is never in binary. Questions is in business is what is actually the trend in numbers and what would I get if I spend say 32K in advertisement. I have the money as a company head. I'm the VP. I want to spend the money, but I should have a notion of how much should I get back. Next, we'll go through how do we do it. The objective is to draw a single line. On the left hand side is the objective is to draw a single line that best represents the relationship between advertising and sale. This single straight line is a linear line. But how hard is it to draw this line? We'll go and say this. Using ordinary least square, we need to fit it well. Let's say all these data points are there and we have drawn a particular straight line. The distance from the point to the straight line is called as a residual, which is basically the actual value of this minus the predicted value. My predicted value is over here on this particular point. Now, sometimes it is on the top, sometimes it is in the bottom. If I do this actual value minus predicted value, sometimes I will get the residual value as positive, sometimes I will get it as a negative. What is the ideal way of eliminating this negative? Any number, any negative number when squared will be a positive number. So what we can do is we can take this number and do a square. When I square this number, I will eventually get a positive number. And we started off with saying the algorithm name was OLS, ordinary, least, and the last one was square. So we are going with the independent words. Ordinary ko chhod ke we have least and we have square. Now we know why this square is required. Why this least is required? Least means the minimum. Minimum means I need to fit a line which makes minimum residuals. Am I clear with this? Is it comprehensible?
This minimum term not getting.
Minimum means I should draw a line such that the residuals, which is actual minus predicted, could be almost the least, that is the minimum. Let's say I have wait up. Let's say I have a data point. Give me a moment. Wait out, huh? Let's say I have a data point. I have many points. 1, 2, 3, 4, 5, 6, 7, 8. There are many points. And I want to draw a straight line. I might not be able to draw a straight line here, but I will try. My straight line should have a particular property in mind while I'm drawing this line. I could have also drawn the same line as something like this. Which makes more sense? The brown line or the red line? I have to make sure that my predictive line goes through the center of my data points. If it has to go through the center of my data points, then what eventually I am making is I'm making all my points least away or the minimum away from this line. Had I drawn this line something like this, then this particular point is way more away from my line than the rest of it. Least square, least, that particular word, least or minimum is I should, in plain English, I should draw a line such that all the points, if combined or aggregated, makes the least or the minimum distance from the drawn line. I could not have a straight line which is very, very fluctuating such that all the points are very away from the base of the line. Did I make any sense?
Yes, sir, clear.
So we were going with ordinary least square, and now we understand why this least word is there. We now understand why the square word is there. Ordinary means it's a very simple equation. Naam de diya isko. That's it. Now, same. We were going with this thing called as a minimize. What we need to do is take the distance or the residual of this point, this point, this point, this point, every single point, and sum it up. Then I have an aggregated residual. And we also said that residuals may be negative because actual one is predicted will be negative, then we need to square it up. So eventually that applies to here. We have a summation of all the squares of independent points from the straight line. So we have summation of actual minus prediction, that too in a square. This we need to minimize. Our objective is to minimize this sum. If we minimize this sum, then the straight line will be eventually going straight through this. Now, I have been saying this word straight line for a long time. What is straight line? Straight line is simply written as y is equal to mx plus c and nothing else. M stands for the slope and c stands for the intercept. My intercept is how much it is from the origin, and my slope is what line does it make with the ground plane, what angle does it make, this theta angle. Now we have to understand this. Y is equal to mx plus c is a equation of a straight line, we all know from our childhood days. Now theta, this angle theta that it extends, or that is a slope, this we very thorough about this. When we try to minimize this sum, what we are eventually or actually doing is trying to figure out the value of theta. We are trying to figure out the value of theta such that this straight line is elevated or downgraded to actually fit these points. So more we have this particular equation to be solved, the more we solve this minimization problem, we are trying to figure out the value of theta, an optimal value of theta, such that this particular straight line matches or goes through the center of the points. Not only theta, we are also optimizing for c, that is my intercept. How much far from the origin it should be, and what should be the value of this particular theta. Summary. OLS stands for ordinary least square. Least means minimization. So our objective is minimization. But minimization of what? Minimization of the square of the residuals. Then what is a residual? Residual is actual minus prediction. But that might be a negative number, so we need to square it up. So we have minimization, sum of all residual square. When we do this, what we actually do is find the optimal value of theta, find the optimal value of c, that is the intercept. Slope and intercept, these are the two values we are actually trying to find. Did that make any sense? Is it clear?
Yes.
This is clear. Why it's called ordinary? What is this ordinary?
What did we draw? We drew a straight line. But had my points be like this, let's say my points are all like this. Can a straight line, I'll draw clearly. Can a straight line actually fit it? Can I fit it with a simple straight line? What about these points left out? Then I need to fit it with this, a carved line. Is it now an ordinary one? It is not. Had it been a simple straight line fit, it's an ordinary least square, which eventually means it is a linear. Linear means it is x is proportional to the y, or y is proportional to the x. But when I have to fit this particular curvature, it is no more an ordinary. It is called as a polynomial, or non-linear fit. It will not be called as ordinary. Since, in short, since we are talking about only a linear fit, it is called as a simple ordinary. Had we gone for polynomials or others, then we should have said that wouldn't have been a ordinary fit. Am I clear with this?
Okay.
Is the answer okay?
Yeah.
Now we try to understand how to fit things, how to do an ordinary least square. Fine. How? Now we will go with how to do this on a example data or actual data points. So we already have some data points here. Let's say we have a Excel sheet, for example, a CSV file with a date, product, category, price, quantity, revenue. If revenue is the one which is our Y, that is we need to predict, then we have 1, 2, 3, 4, 5. 5 independent other modalities or dimensions. Now I'll be very slow. Do all dimensions make any sense to ordinary least square? What does ordinary least square require? Data points on a chart which is two-dimensional. So I drew an Y and an X. When I was drawing these points, it was two-dimensional. This is one-dimensional, this is two-dimensional. So it's on a X and Y plot. If I take all these data points, 1, 2, 3, 4, 5, would that make any sense? Or no? It won't make any sense because ordinary least square right now requires only two independent dimensions. Therefore, I have to remove all these independent dimensions. I have to keep only one. Either I keep date or product or category or price or quantity. I'll go again very slow. Judging from this particular data set, from a human intuition, what is the or what are the actual dimensions that is usable? There are certain dimensions which is not usable. When I say dimension, I mean the names, these products, categories, price, quantity. OLS requires to be in X and Y, which is two-dimensional. Done. We now know that we need to take only one dimension from this. OLS also requires for all the values to be numerical. That is actual minus prediction. If I have to do, then I have to have numbers to subtract. Out of this, date, product, category, price, and quantity, which one do you think is non-numerical? What are the things that is non-numerical?
Product and category.
Correct. So if I remove this product and category, two things remains: price and quantity, as well as the date. Date is somehow, let us think of it as a numerical one. If we remove these slashes and all, it is still a numerical one. I mean, we can quantify that. So date, price, and quantity, these are the ones that remains. We started with this lecture by saying there are two type of things: regression and classification. If I have to have this data set entirely, let's say we have unbridled data set. Now, based on this price and quantity, had I to classify the product in category, then that would have been classification. But what we need to do right now is we are focusing on only one thing, that is regression. My objective is simple. My objective is for the category accessories, given all the dates starting from January to December of the year 2022, and we have all these numbers, I need to predict for my sales boss what would be the number for January, February, March of 2023. 3 months or a quarterly advance prediction. If my boss wants it, how do I do it? I can use this OLS. Only and only when do I use this OLS? When I see there is a proper variance. I mean, there's a proper bias. If I seen my data points after plotting. Anybody can do. After plotting, if I see my data point is very fine, there is no issue. Go with ALS if it looks linear. But if there are outliers here, here, you need to identify these outliers first. This is an outlier, outlier. If you do not remove this, then your straight line would be something like this or like this, which do not make any sense. So remove this outlier such that your data points make more bias and you can actually draw a straight line. Now you have a Excel file. Now you know that there are two dimensions which cannot be used for regression. You removed it. Now for the category accessories, given this quantity, given this date and this revenue model, I need to forecast the values of January, February, March. Should I start directly with OLS right now without even glimpsing or looking through this data? No. Your first job when receiving this data is do EDA. As Dr. Thakur had been saying, we need to do this EDA, another jargonic name, but which eventually means Exploratory Data Analysis. If you go by the name, it really means we need to explore the data and analyze it. It's a very jargonic name, but in the end of the day, we need to do only few things. First, when we receive the data, find out if there are any missing points. What is missing points? What is a missing point? I should go with a new one. Yeah. Your primary would be missing points. See, in this data, somebody from the sales department, maybe the sales was low and it was not reported. In such a case where we have a missing data, what are the things that we can actually do to make sure that there is no missing data? If there is any missing data which is actually a null value, so when you do actual minus predicted, you do not have that actual, so it is becoming null minus something predicted, which is absurd. So you need to fill this up. This missing data has to be filled up. There are many ways of filling this up. One of the easiest way is take the average of the last 3 or 4. 3 or 4. When I say 3 or 4, that is also known as a window. Window size is all up to you. You can take 5, 6, 10, but that is a rolling window. For example, 1000 is also absent, and I am taking a rolling window of 3. So 1500 plus 2400 plus 1200 average goes here. If I do not have this value. Similarly, if I do not have this value, 1600 plus 1200 plus 1200, and then do the average and then fill it up. But end of the day, you need to find out if there are any missing values and you need to fill it up. Without filling out any missing values, data is meaningless. Second thing is data scaling. This is quite important, but not so important for OLS. But for later ML and DL, you will be requiring this. But you should know what is scaling. By intuition, by simple human intuition, if I go with these values, my price has a range. It might have a range from let's say 50 rupees to 1,000 rupees. Whereas my revenue may have a range from say 900 to 12,000. These two values, these two ranges, not values but ranges, actually have a very high variance. Variance means departure from the median. So median for this is around say 1600 or something, maybe, but the variance here is less, the variance here is more. What do we need to do? Do I keep these ranges as is, or should I do something else such that it makes more sense? We can do something called as a scaling or data scaling. What we do is, what is the highest value of price? 1,000. So what I do is, I take 1,500, 150 divided by 1,000. So this becomes 0.150. This becomes 0.2. Similarly, for the revenue, what is the maximum value? For the time's sake, let us take it 10,000. That would be easier for me. If the maximum value is at 10,000, I will divide this by 10,000. So this becomes 0.15. This becomes 0.24. What I actually did is, if you notice very carefully, all of these values for the price as well as the revenue, all will now have a single scale from 0 to 1. Now when I have all this as a single scale and I know how much I have divided with it, then I can scale it up while prediction. So data scaling is a process of putting the required dimensions, all the required dimensions into a single scale between 0 and 1. What we actually did is called as a normalization. In statistics, it is known as a simple normalization. So normalization is important. You can have any other scaling methods also, standard scalar, minimax scalar. There are many more scalars. I'm not going to the depth of it, but normalization eventually works because we need to tighten up the scale such that our predictions are quite proper. Again, is this understood, scaling and the requirement of it?
Sir, can you please explain that once again?
Yeah. Let's say in a class, same with students, you want to understand the relationship between your students, extract, MAR points, mandatory requirement points, how much they have participated in your college fest, tech fest and all, that relationship with their CGPA. Now CGPA has a standard. It has got a scale. It has got a scale between 0 and 10. Whereas your extracurricular activity point scales from 0 to 10,000. So what you are actually doing when you need to plot these things up, what you will have to do is, you need to understand their CGPA and their MAR points, mandatory points, extracurricular points. Now these points are from say 0 to 10,000. So obviously this scale is from 0 to 10,000. And this scale, CGPA, is between 0 and 10. So I'll be putting, if this is 0, I'll get a 10 very close, 10 here. Now if I draw all the points, relationship points, I'll get points like this. is it easy to understand? Or is it easy to draw that straight line? Not really. But if I do this normalization, then both my scales are between 0, 1. Here also it will be between 0, 1. Then the points, data points will be very easy to understand and in a proper clustered way. Because we have normalized both the scales in a single scale. We have not taken their own main scales, but we have changed their scales in between 0 and 1, such that my plot and my points are all at the same page. I want all my data points, all my dimensions at the same page.
Dr. Banerjee,
Yeah.
we have 15 more minutes, okay? Just to remind you. And one thing I would like to say over here, just in continuation with you, many people are there from medical background. So what is the need of this data scaling? Is that suppose for any kind of diagnosis, we make some kind of blood report analysis, isn't it? Suppose for CBC analysis. So in there, some hemoglobin parameter is also there, WBC platelet counts are also there. So WBC, RBC, WBC platelets comes in millions, like 2 millions or 50,000, 70,000, something like that. That is the range, normal range. But for hemoglobin or something like that, it comes in the range of 8, 9, something like that. So if we do not scale all the parameters in a single scale and directly put into any kind of learning model, then obviously model will put more emphasis on the parameters which have a larger values and less emphasis or less importance for those parameters which is having the lower dimension. So which should not be the case. But to get rid of that particular scenario, we need a scaling kind of thing.
Yeah, understood, sir. In the practical example, professor showed some how to make it 0.15 or something. He showed in the example. So that only I wanted some clarity.
Oh, so you wanted to know how this is actually done?
Yeah. That's all.
Let's say in the revenue section, we have my revenue starts from the range of 0. And I know that my maximum revenue, what is my maximum here? 1500, I can see 1500 here, I can see 2400, somewhere it was 2400.
Okay, doesn't matter. Yes. Okay.
Whatever is the max. Okay. So let's say 1500. So my value of X, this is my X divided by, let me say this as dim max. So dimension ka max. The current value 1500 divided by what is the maximum of this, all the numbers. That makes it in between the range of 0 and 1. How? Let's say the maximum is 2400, right? So my 2400 is the actual value divided by the maximum value 2400, which is 1. But for this point, it will be 1500 divided by the maximum value, whatever it is, say something 0.2 or something, 0.6.
Okay. Good. Thank you.
Okay. Okay. Now we know why we need data scaling. Data scaling, I just showed only one type, which is normalization, which is the nominal one, and many more scaling options. Now, I'll go with the code. As I was saying, the first stop for data is data EDA, Exploratory Data Analysis. I'm very much sure you are not acquainted with Python, you are not acquainted much with programming and all. Not all of you. Somebody will definitely be acquainted with, but not all of you. So I will be very slow. Python is a programming language.
So, Dr. Banerjee, will you share the code and the data with us so that we can practice? Those who know.
Absolutely. I'm not acquainted with the modality of this sharing thing. Once I get to know it, I'll share it.
Sure. Thank you.
Okay. The people, Python is a programming language. in any programming language, you can start writing things from scratch, or you can borrow knowledge and code from others. One of this borrowing thing is called as a package. Let's say I am writing a code for a particular thing, area, and I require some tools. Those tools in Python are called as packages or libraries. One of the libraries is called as a pandas. Another, this pandas library is mostly used for data analysis, data pre-processing and all. Next we have matplotlib and seaborn. These two are majorly used for plotting. So those hand-drawn plots that I was doing, those will be rubbish for a VP of a sales. He or she will require a proper plot. To do that, we require these two libraries. And to properly analyze, we need this pandas library. Now, I have this sales data, which is exactly this. And I need to do first and foremost one thing, which is data quality check. Is it visible, or should I now is it visible?
Now it is visible.
Yeah, it's visible.
So data quality check is the first step that we need to do. Or in data quality check, the first step was that we learned is check for missing values. Now, this is row 1, 2, 3, 4, 5, 6 is the rows. These are my columns. I have to have a row column matrix. When we see an Excel sheet, we do not intuitively think of it as a matrix, but this is basically a matrix of X and Y. So we have got rows and columns. What we need to do is, first we are doing a step one, we are previewing the data. Let's go with this. If I run this code, I'll run it again. So we have the first 5 rows, exactly what you have seen here. These are my first 5 rows. These won't match with this. If I put them side by side, they won't match. Why? Because they should match, because I have taken only the first one. Yeah. Watch, smartwatch, they're matching. Next is what we've done is types, data types. We had said that some of the dimensionalities of the columns will not be required or not suitable for OLS because they are categorical types and not numerical types. So we need to identify which are the columns which are numericals, which are the columns which are categorical. Obviously, date is a categorical, but we can transform this into a numerical one. But certainly, product and category, we cannot transform them into a numerical one. We can, that is a separate issue afterwards, but not right now. But we have price, quantity, and revenue as floating numbers. Forget about the 64. That is bit by binaries. Now, price, quantity, and revenue are actually numerical numbers. It could have been integers, it could have been floats or long integers, but two types, integers or float. Right now, we see that they are of type float. So, usable parameters are price, quantity, revenue, out of which revenue is my Y and price and quantity is my X, since I'm trying to predict this revenue. Fine. How many rows are there? How many columns are there? Rows 369 and columns is 6. Now, the primary job was to figure out, was there any missing values? To figure out the missing values, we did a check and we found out data has got no missing value. Price has got 2 missing values. Quantity has got 1 missing value. Revenue has got 1 missing value. What do we do then? I need to have those values. If I do not have those values, I can do a rolling average. Let's say I do not have these values, and I take the last 3 numbers or the 4 numbers. That number 3 or 4 is your window size. Based on your window size, take the average of this and put it here. But you need to do it. Without this, predictions will be absolutely haywire. There are people who do this. When I see a blank, I put a 0 and go on. Does that make any sense for a sales forecasting or any other forecasting? Because the moment I put a 0, that is a numerical value, and which is a wrong value. I should not put a 0 or a null value in any sort of missing values. The ideal solution is to go with the rolling window. Okay. Now, missing values imputation, that is done by this rolling window, it will be done. Then we need to find out how many rows are duplicate. Is there any duplicate rows? Duplicate rows means this row, I have one more. These two are now duplicate rows. If I have duplicate rows where all the numbers are actually the same, does not make any sense for prediction, because it adds up with that value actual minus prediction. We are doing it twice for the same point, and then we are aggregating it, we are summing it. The summation will be wrong. So we need to find out the duplicates and actually remove them. Next is we have missing points, data scaling, feature engineering. How do I write this feature engineering here? Next point is feature engineering. Your every single point is basically a feature. Let's say, what is this feature and how do we engineer it? We need to understand this first. Let's say I have 1, 2 independent parameters or these columns. And in a class of the same students, based on their pencil size, the pencil that they bring to their classes, school ka bacche hai, the pencil that they bring, some of them are short, some of them are long. Depending on their pencil size, I need to predict their term and score. That does not make any sense. So I need to figure out if I have inadequate or wrong number of parameters, what other parameters can be derived from the present parameters such that they make sense for prediction, actual prediction. Example, in this particular situation, date. A date has got few other derived values. One of them is this a weekend or not? So I can have 2 more parameters. One of them is weekend or not. What can be the other parameters? The actual day. Is it a Thursday, Monday, Friday, whatever. Another thing is, from this particular date, I can also have the month. Eventually, I am deriving more meaningful data from the present data itself. Now, you will say weekend. Yeah, this is a true or false thing. I can write, is it a weekend true or is it a weekend false? So that will be not be counted since it is not numerical. But we can be clever and write it as true as 1 and false as 0. Now it is numerical. So we have more numerical values. Now date. Similarly, day will be Sunday to Monday or Monday to Saturday. But eventually there are 7 days. It's a finite number. So we can go with 0 to 7. Sorry, 0 to 6. There are 7 days. Month 0 to 11. For non techies, it will be 1 to 7. This will be 1 to 12. So now we have engineered some features which makes more sense and provides more meaningful insight to the data, which was originally not in the data set. This is known as feature engineering. We are engineering some new derived features which makes more sense for proper insight. Am I clear with this? Is it understood?
Yes.
Okay. Now, after feature engineering, so we are going step by step. Missing point, yes. If there is a missing point, do imputation. That is also a jargon. In short, in very simple terms, fix it. Put a value using rolling window. Next thing is data scaling. You need to scale all your data points to be in the same scale. You need to, I should not say the word need to, you should. If you do not do it, you will take time to understand. The system or the statistical model will take time to understand the data. And as Dr. Thakur had rightly said, it will be biased to that particular parameter which has the highest variance with the largest number of range. It will be obviously biased to that particular parameter. You should do it. Is it a must? No. Missing value imputation, is it a should or a must? It's a must. So first point is a must. Missing value is definitely a must. This, yes, maybe you can do it depending on your data. Then was feature engineering, which eventually I removed, I guess. Then it was feature engineering, which you should do, absolutely should do. If you feel you have very few parameters, say 5 or 6, then you should do. When you see you have 1,000 parameters, do not do it. If you see 1,000 parameters, do not add more parameters. Then your job is exactly the opposite of feature engineering, which is dimensionality reduction, which will be called as dimensionality reduction. So basically, when what did I do? So basically, when you have little to no data points or parameters, go with feature engineering. Must. There is a must. When you have very high parameters, of which most of them are redundant, useless, meaningless, go with a dimensionality reduction. To do that, you need to understand which one makes more sense and which do not. For example, here, when I am trying to figure out the revenue forecast of this particular category accessories, obviously my price do have more importance than the quantity being sold. If the price is very high and I sell very less, then too I will make a good revenue. So either you put your effort in price or in the quantity, depending on your use case. But end of the day, both this price and quantity will have their own weightage. To which dimensions you put more weightage and to which you do not depends on your use case. If I have to figure out how many quantities have been sold. Depending on that, I need to focus the revenue. Obviously, my quantity will be more important and I will remove price, and vice versa. But had there been 1,000 dimensions, many dimensions, then you need to figure out which one makes more sense and which one do not make any sense. Example was that pencil. The pencil has the size of the students' pencil that they bring to their class has got no meaning to the actual prediction of the term and exam.
Dr. Banerjee, probably we
excuse
can
me.
continue from tomorrow. Okay.
Okay.
Because already time is over for today. So what we can continue the rest of the parts, like the training and the rest of the part of data exploration and feature engineering tomorrow. So I think if Mr. Datta is over here, then we can conclude for today's session.
Yes, sir. Thank you very much for the wonderful sessions, both of you, Mitra sir and Abhijit sir. We shall continue tomorrow at 3 o'clock. Sir. Thank you, everyone.
Okay. Hope it was meaningful for somebody.
Yeah,
Yes, sir.
and if anyone have any questions or queries regarding today's discussion, you are always welcome to ask.